Okay, let's continue on the table number 1. The ruler, the least count is about 1 millimeter, and the uncertainty of the least count is uncertainty of the ruler is 1 over 2 of the least count, which means 0.5 millimeters. And you just need to multiply each of these number by 10 to the power minus 3 to get into the unit meters. It's going to be 0.5 times 10 to the power minus 3 in unit meters. And then vernier caliper, which we use 0.05 millimeter level, half of that 0.25 millimeter level. This is going to be then multiplied by 10 to the negative 3, each of those numbers, right? 0.05 times 10 to the power minus 3 in meters, 0.025 times 10 to the power minus 3 in meters. And the screw gauge, 0.01 millimeter level, 0.005 millimeter is the uncertainty. Then this is going to be 0.1 times 10 to the power minus 3 meters, 0.01 times 10 to the negative 3. Then this is going to be 0.005 times 10 to the power minus 3. In unit meters, and the triple beam balance 0.01 grams, 0.005 grams, 0.01 times 10 to the power minus 3 in units kilogram. What we interested here, because SI unit is kilogram, so this is going to be then similarly 0.005 times 10 to the power minus 3 in kilogram. Okay. All right, then let's go into the table 2. Table 2, we have the data set. So to make sure the units, we are using the unit of centimeters. Micrometer, always we need to take care of the zero error, right? So the one I use had about 0.01 level of centimeter zero error. So I have to add that all the data I actually measuring. Okay, then we take care of the zero error for the micrometer, and then we have all data. Then let's take the average, equal average command, and the data set go from C20 to C23. C23, and since I'm doing the same function, I can click this dot, solid dot, just bottom here in this cell, and then drag to the right direction. Okay, that will do automatically. The function is right here. And then similarly, if I take the average of data, then the error will be the average error. So I can do that by using the mean deviation equal. If I put the AV, I can select the right command. AVE DVE returns the mean deviation of the average C20 to C23 data set only we need to give, and the Excel will take care of the calculation. Right, so the only thing, if you take a look now, all of these I need to have actually 4 decimal places because of the micrometer, and all of these numbers we can clearly see the measurement error. The instrument error is actually not same as the calculated mean deviation. Okay, average error. All right, table 3, the mass we measured, the least count is 0.01 in gram. I add the 0 extra because we can estimate the next decimal place. Unsaid because of that 0.005 unit grams. Let's calculate the volume. So the cylinder is pi r square times the L. Since we measure the diameter, it's going to be pi d square or 4 times L. The function is right here, equals pi pi open and close bracket is the command for pi, right? So multiply by parentheses C24 to the power 2 divide by 4 times D 24. And that will give you the calculation, and the rectangle is the length average E24, width average F24, times the thickness average G24 from table 1. And function is right here. And then we need to calculate the error, right? That is a part we skip in the class. Now, when we're doing the error, now let's consider now this error is still the same unit, okay? The centimeter cube, but we need to figure out the error equation, right? Remember, we discussed in the chapter, in the first class, if I have a multiplication, division, or addition, subtraction, error equation going to be based on that, right? So in this case, error going to be delta times the V, which is equal. Now you can clearly see the pi and then 4, nothing, it's not going to participating. So what participating is actually these two, right? So the D has a power come first, delta of D divide by D parentheses to the power 2 plus delta of L divide by L to the power 2 square root of everything. And then front here, everything has to multiply by the volume we calculated. All of these are the average values, and the error values are the mean deviation. Okay, so we just need to write this function equal sign the volume we calculated multiply by square root in Excel sqrt, and then open bracket sqrt is the function inbuilt for the square root. Okay, open bracket, open another bracket for this inside right here, and this is 2 multiplied by mean deviation for the diameter divide by the diameter itself, close bracket, power 2, plus open bracket, mean deviation for the length, divide by the length average itself, close bracket, power 2, close bracket for the square root, hit enter. So that's it. Let's look at that function. I will copy paste that function somewhere here. See, let's get rid of the space there. All right, let's put that function here. This is the uncertainty for cylinder. Okay, so let's write it down. Delta V for cylinder. Make sure that is visible. Okay, now that's a function. Okay, so this is the real function, how it looks like. That is the function after we put it in. Now the errors we need to round by looking into the number of decimal places, right? If I have a 3 decimal places, any error showing anything more than that decimal places has no any meaning. So you have to show only 3 possible decimal places. Okay, and then similarly I can calculate for volume. Now first I need to take a look what's the volume equation. So let's take a look. Volume equation. Volume equation going to be look like this. Volume for the rectangle is basically length average times the width average times the thickness average. This is multiplying 3 of them together. Therefore, the volume error for the rectangle is volume calculated is square root parentheses mean deviation for the length divided by length is square plus mean deviation for the width divided by the width is square plus mean deviation for the thickness divided by thickness is square root of everything. So we just need to write that in our Excel function right here. Let's do that equal sign volume multiply by SQRT, open double brackets, mean deviation for the length here divide by the length itself, power 2, plus open bracket mean deviation for the width divide by the width itself, close bracket power 2, plus open bracket mean deviation for the thickness divided by the thickness, close bracket power 2, close bracket for the square root. Then we'll cut down the number of decimals to match with only the decimals we can show, which is only 4, right? So that's the idea. That error, that is small error there, means our measurements are actually very good. That what that does that means? Okay, if our error are bad, then we will get a large numbers there. This is going to be then delta volume for rectangular shape object. Okay, so that's let me. All right, so that's the two equation needed on there. Make sure you do that carefully. Add the equation just below here, and also try to understand how we write it down these formulas by looking into the equation we are using for the volume. Okay. Now, what we really interested here, these numbers, right? You can see these numbers nothing to do with the measurement error. These numbers are completely different than the measurement error, and particularly for rectangular object, you can see error is extremely small. Okay, that's very important. Then let's move into the next part. And we already did this calculation. Let me go over again. The density is very basically mass or volume. We are using the same unit, gram per cubic meter, equal mass we measured for cylinder divided by the volume calculated here. And just similarly, I can click and drag because it's the same column doing the calculation downward function right here. And then what we needed to do, let's do the percentage error also first. Equal ABS open bracket expected value minus the calculated value divide by the expected value divide by expected value multiply by 100. Then you click and drag. Any percentage error, only two significant figure visible, not more than that. Only two fix visible. Any calculated error, the amount of decimal places has to match with amount of decimal places in the number. Okay, that's the rule we following for the errors and percentage errors. Two different things. Okay, error has to reflect the accuracy. Calculated error has to reflect the accuracy. Percentage error nothing to do with the accuracy because it's comparing two numbers. Now density error on the other hand, it's very similar like we did earlier. Gram per cubic centimeter. Density formula is very simple. Density is equal mass or volume. This is like dividing two numbers. Then the division rule. Error for the density is equal density multiplied by square root. Error for the mass over mass to the power 2 plus error for the volume over volume to the power 2. That's it. So it's a very simple. So let's write it down, that function equal the density we measured multiplied by SQRT, open double brackets, mass error for cylinder right here, divide by the mass of the cylinder, close bracket, power 2, plus open bracket, volume error for the cylinder, divide by the volume of the cylinder, close bracket, power 2. Close bracket for the square root. Now this error again I have to cut down to only 3 decimal places. Anything more than that has no any physical meaning. So this is going to be the delta density, density for cylinder. All right, so that's about it. Let's then take a look. All right, so we'll do the same way for the rectangle, but the rectangle actually you can see the same equation for the density. And I'm basically doing the same rows and columns in previous table. So I can actually click this and then drag downward. It will do the calculation automatically. You can see compared to the calculated density value, these are really low. That's why we need accurate measurement. That's the idea of using vernier caliper and so on. Then the final one, we just need to write in standard format. Standard format always, whatever we calculated, we calculating row plus or minus what is the error we calculating, and SI unit. SI is kilogram divided by meter cube. Okay, so since we put the kilogram meter cube here, we don't need to re-put there. But I will add the units into the format. Then it's actually much clear. If you have the units here, then we don't need to re-put the units. So in this case, instead of just typing, it's better to use insert on the top menu and the symbols equation. Then you click and drag the equation wherever it's supposed to go. Then you use the equation formatting tool to actually write it down. This right equation formatting tool is right here. Equations, And we need density of the cylinder 2.834, 2.834 plus or minus. You have to find that tool from this equation toolbar, plus or minus. And in the area of density, we calculated 0.011. 0.011. That's it. And the units, we put it on the top. You don't need to have that again. But I need to have this unit. The unit we are using gram per cubic centimeters. And if I convert this into kilogram, this will be 10 to the 3 times kilogram per cubic meter, right? So that I need to add here. So let's put the parentheses for this and add equation power sign right here. 10 to the power positive 3. Now everything is good. Similarly, I need to retype this for rectangle. I'm going to make a copy. I just copy paste that equation and then I'm going to edit the number, right? For rectangle, I got 2.704, 704, and then the error I got 0.022. So 0.022 and 10 to the power 3 is still the same, okay? That's about it actually. So fairly very simple. These answers, you can easily write it down by reading the lab manual. Only thing I need to point it out earlier is the Archimedes method, which means the volume displacement is the Archimedes principle. We can use that method to measure volume of any object. And it particularly useful if I have an object with improper geometries, which means the dimensions are not possible to measure directly, right? And the specific gravity is the relative density, which means or any given number, if you divide by 1 gram per cubic centimeter, you will get the number itself. This is a unitless parameter, which is very important parameter to understand whether something sinking or floating on the water. Okay. And then here in the discussion, you need to write a discussion for this, which means the discussion, when you write in the discussion, you have to discuss about each table. A small paragraph, which means we had 4-5 tables basically, just couple of sentences for each. Okay, you have to write a couple of sentences for each tables, and then you have to write few sentences for each table, and then you have to write one simple paragraph, one last paragraph for paragraph of conclusion. So this conclusion paragraph is actually what it reflects. It actually reiterating the objectives of the experiment, whether we accomplish the experiment properly or not. That's it. So I will stop from here. See you guys next week then. All right.